Thanks, Rick. Good morning. Please adjust this greeting accordingly for your time zone. I am Michael Klein, the developer lead in Northwestern University Library's repository and digital curation work group. And I'm here to talk about what's new and hopefully improved in the serverless-iiif project since I presented on it last year at Samvera Connect. This is the slide I ended on last year, showing some of the work that had yet to be completed, including deploying serverless-iiif here at Northwestern. We were using something based on a lot of the same code, but we were not actually using the serverless application that was published to Amazon serverless application repository. I am happy to report that we are 3 for 4 on this slide. We are now using serverless-iiif in both our staging and production environments. We have a workaround for the 6 megabyte API gateway limit, which I will define and address a few slides from now. Authentication and authorization are now possible through CloudFront trigger functions or hook functions. We're still using the hard-coded tile sizes and scaling listed in that third bullet point, but we'll get there eventually. It's nice to leave something for the future. One of the big changes this year is the transfer of ownership of the 2 core repositories in the project from the NU Live GitHub organization to Samvera Labs. I first proposed the transfer in the dev Slack channel on June 1st and was met with a lot of enthusiasm. I then spent 3 weeks trying to make sure we had contributor license agreements from all previous contributors and their institutions, according to Samvera's policy. And finally switched everything over to Samvera Labs on June 24th and added Dan Wolf from Notre Dame as co-maintainer of both. The hunt for CLAs led to a number of conversations involving Samvera's CLA requirement and whether it represents an unnecessary barrier to entry for contributors who might be loath to sign or may not have an attorney to review what they're signing. Other large open source projects and communities seem to get by okay without signed CLAs, and I think it's worth considering whether we can too. But getting off my soapbox there, I would like to really thank Heather Klein and Jeremy Friesen, who has since moved on to other opportunities, for helping me wrangle all of that legal stuff in the meantime. This is last year's architecture slide. We had 5 main components: the iiif processor Node.js library, the serverless-iiif Lambda function wrapper, and the serverless application repository application that goes along with it, that wraps the iiif processor library. The Amazon API gateway that allows us to establish a REST API to convert web requests into Lambda calls. An Amazon Simple Storage Service, or S3 bucket, for image storage, and the serverless app repository for application packaging, deployment, and versioning. We've added a couple new components, so we need some more room on this slide. We've added support for a caching CloudFront distribution that sits in front of the REST API and which also figures heavily in the workaround for the 6 megabyte response limit. And with CloudFront, we gain the option of attaching pre and post processing functions to the whole operation, which I will also address soon. I want to talk a little bit about getting around this, this limit that I've been talking about. AWS API Gateway has one major limitation in its REST APIs. Neither the request nor the response payload can be greater than 6 megabytes. And that is the base 64 encoded response. So the actual data response is more like 4.3 megabytes, but I'm going to keep using 6 just because it's easier. As a result, serverless-iiif up till now has had the same limitation, preventing us from returning some images at full resolution. But we managed to come up with a workaround that allows responses of any size without sacrificing speed or scalability, and without any kind of weird redirecting, which would make the URL change on the browser side, which, while invisible to most users, irritates me enough to have given me motivation to try to avoid it. The solution lies in CloudFront's ability to fail over to a second origin if the primary origin returns an error. It works like this. When CloudFront receives a request, it first checks to see if the object is already in the cache. If so, it returns it. So far, so good. CloudFront just doing its job, nothing required from us. If not, it sends the request to its primary origin. Now, an origin is simply a backend source that responds to path-based requests like URLs and returns data. It can be an S3 bucket, a REST API, or really any other arbitrary HTTP resource that is reachable by CloudFront. In this case, the primary origin is a REST API defined by AWS API Gateway that invokes the IIIF Lambda function and sends it the request information as a request event. The Lambda function then finds and loads the requested image from the S3 image storage bucket and processes it in accordance with the crop, size, rotation, and format parameters in the request. So far, this is how serverless IIIF has worked all along, including up until last year when I was presenting on this. But here's where it starts to look like a bit of a shell game. If the resulting image fits in less than 6 megabytes for that response payload, the function just returns it to the API gateway, which returns it to CloudFront, which returns it to the viewer. Standard operation, no workaround visible yet. This is just how API gateway works. But if the resulting image is greater than 6 megabytes, it instead writes it to a specially configured S3 bucket using the request path, this ID / IIIF parameters path as the S3 object key. So it's stored in that directory within that S3 bucket. It then returns a 404 not found response to the API gateway, which passes that response along to CloudFront. CloudFront responds to the error by resending the same request to its secondary origin, which in this case is configured as that same failover bucket where we just wrote the correct response a split second earlier. Since the response is stored using the request path, CloudFront finds it there and is able to return it to the viewer. And because it's just treating that S3 bucket as an origin, CloudFront's same caching configuration and caching behaviors apply to whatever it finds in that failover bucket. So it is transparent to the user, it's transparent to the cache. It's just this workaround that lets us say, hey, you know, this piano won't fit through the front door, let's push it out through the garage. And have the moving truck come get it from there. And this pattern will actually work for any API gateway resource backed by a Lambda function where a given request path always generates the same response. So it's not great for things that can change dynamically based on, say, like posted data or things with query parameters, unless you include those in your cache key. But it's actually a great general purpose workaround for any API gateway. Also, since we're using CloudFront for large responses and caching anyway, serverless IIIF now also supports linking viewer request and viewer response functions to its CloudFront distribution. These functions are distinct from the main IIIF function installed by the serverless application and have to exist. They must be created and deployed before the serverless application is installed. The pros and cons of CloudFront functions and Lambda ed-eng functions and how to create them and how to configure their permissions and everything is way beyond the scope of this talk, but I am always happy to answer questions or provide feedback or pointers on Slack or via email. The viewer request function is invoked as soon as CloudFront receives a request. It's invoked even if the requested URL points to something in the cache, since just because something's in the cache doesn't mean the requester is allowed to have it. A viewer request function can alter the request before it gets to the CloudFront origin, adding headers, changing the request path, changing the cache key, or any number of things. Serverless-iiif leverages the ability to alter the request by looking for two custom headers, X pre-flight location and X pre-flight dimensions, that can be added by the viewer request function to provide the S3 location of the full image or the image's full-size dimensions. People who have seen previous editions of this presentation may remember that if your images were stored in a path other than what the function expected, you had to fork the repo and deploy your own version of the project instead of deploying directly from the serverless application repository. But now you can just deploy the published app straight from AWS and install a viewer request function to handle your resolvers. If either header is present, its value will be used. If not, the default resolver will still be used for that value. So you could provide a location, but not the dimensions, or the dimensions, but not the location, or both. The viewer request function can also immediately return a response that is sent back to the requester instead of forwarding the request to the origin. This can be used to override the response completely, such as redirecting the request or returning a 401 or 403 status auth failure. For example, our viewer request function uses an encrypted user token in the request headers along with item visibility information stored in Elasticsearch to determine whether access should be granted to the requested image. Viewer response functions are invoked just before CloudFront returns the response to the requester. It can override any part of the response, for example, to add cross-origin resource sharing headers, or even to make a late decision to redirect or deny access, but it does not receive a copy of the Lambda-generated response body. This is because of that 6 megabyte limit. There's really no great way for us to allow it to be passed through because of that limit on Lambda functions. But if we figure out a workaround, maybe it could be used in the future, for example, to watermark full-sized images on request. There are two more CloudFront hooks that we don't use, but that are supported by both CloudFront and serverless-iiif. Origin request and origin response. Origin request happens between the viewer request and the CloudFront request to the origin. And the origin response happens on the other side after the origin request, but before the viewer response function. So it goes viewer request, viewer response, origin, origin response, viewer response. I hope I got that right. The origin response is particularly useful when you want to alter the response such that CloudFront caches the altered version. So the origin response trigger happens before CloudFront caches and writes the response to its cache, but the viewer response happens after that. So you're altering the version pulled out of the cache also. But origin request and origin response are not invoked on a cache hit, which is important. Viewer request and viewer response are invoked on a cache hit. And that brings me to the end of the new features. I know it was pretty dense. I'm happy to take questions or comments either now during the remaining few minutes of the presentation time, or at that email address displaying there, or on Slack or you can find the repos on GitHub and tag me in issues.
Thank you, Michael. And I'm looking at the Slack channels as well as the Q&A. There's nothing in the Q&A at the moment. I did see one question in the Slack channel that may have been resolved already, I think from Jonathan Rockhind. I'll just repeat it very quickly. Unrelated, but curious about what you know about people using your IIIF servers beyond your own apps using it. What are their context use? What are the use cases or context there?
I know it's in use at Princeton, and I am sure that Trey would be willing to answer some questions about their experience with it. I also know from chatting with Trey that they are sort of up to date on having installed the last version that supports the hooks. I don't know which features they're using, but I know it's there. I think Notre Dame also has it running. I'm not sure if that's just in a test environment or if it's actually in production. The Royal Pavilions, Brighton, and Hove in the UK, Ed Silverton from Nemesine has it running. And I also wanted to mention that I didn't have it on a slide, but since we've installed it, I know it's been running. This version has been running about a month with our viewer request and viewer response functions. So 3 Lambda invocations per request, unless there's a cache hit, and a lot of image processing, a lot of data passing through here. So, and in the past month, this has cost us about $30 to run. That includes the Lambda invocations, the caching, the data transfer, not the data storage, that's separate, because that's part of our preservation budget. But yeah, it's cheaper than running a dedicated server.
Great. Okay, there was one more question from Trey Pendragon. If I install this and have a bug, what's the best way to report it?
Through the Samvera Labs for now. Hopefully it will be promoted to Samvera soon. But right now the projects are Samvera Labs, serverless-iiif, serverless-iiif, and Samvera Labs node-iiif on GitHub. And if you can suss out whether the bug is in the core IIIF functionality or the wrapper function, the Lambda wrapper function, that's great. Otherwise, feel free just to send the bug to serverless-iiif and we'll triage it and figure out where it belongs.
Great. And I see one question came through in the Q&A, just beat out David Schober by a millisecond, I think. So from Anthony, I've tried this and seems to work great. Are you aware of anyone who has investigated something similar on other cloud platforms such as Azure? I
do not. I know I've received some questions about whether we have plans to make other platform versions of this available. Unfortunately, I don't have the resources or access or the time or a use case at the moment to justify spending a lot of time on it. I'm definitely open to the idea. It would probably be a separate repo for each version of it. But the core concepts, I'm sure, apply depending on what features those other cloud platforms have.
Okay, 2 more questions in Slack now. So from David Schober, any designs on promoting out of labs, ?
Yeah, I mean, that's definitely something we want to do. We have to look back at the criteria. I know there have been a flurry of pull requests, thanks Kate Lynch for most of those, to improve the README, to add certain required files, to do, I think, branch renaming, various things that can get us out of labs sooner. I know I'm at the end of my time. I do want to mention that we currently support the IIIF image API version 2.1, There's a standing issue feature request to support 3.0, and that's something we're going to look into as well.
Great. Then a question from Michael Johnson, random fact. That's also my dad's name. What role is Node.js playing here?
Node.js is the Lambda runtime for all of the code that's running. So everything that is in this part right here is written in Node.js. It's running on a Node 14.x runtime with some external modules and support code. But that's where Node.js comes into it.
Great, and I think there was just kind of more of a random comment from Carolyn Casey that we need another partner to put it into production. I think question mark requirement is 3 question mark. I think that is true.
Yeah. I'm sorry, the question is about whether other partners have put it into production?
I think so. Like, have we met the requirement of 3 yet?
Yeah, I think so. Assuming Notre Dame's is in production, but we definitely have 3 in production, us, Brighton and Hove and Princeton. So, you know, I'm pretty sure we're at that threshold.
Okay, I'm not seeing any other questions. We'll wait another moment here. Okay,